Welcome back to new exercise in SolidWorks. Here we will make 90-degree V-twin engine in SolidWorks and we will learn part modeling and assembly, and also we will make animation at the end of video. I hope you like it. So let's start to create this simple animation and assembly in SolidWorks. Let's make first part piston of V-twin 90-degree engine. So here just zoom. All dimensions are in millimeter and material is steel polish, and see check video. Okay, this is our first part piston. Now overall length is this piston is 70 millimeter. Diameter you will observe from here 70 millimeter. Then there is one dome shape 5 millimeter. This is also going to add, but from inside you will see 6 millimeter thick. You will see here the inside diameter 58. If you calculate that wall thickness going to be 6 millimeter. So this is we are going to make. You will see 3 number of piston rings slots. So you will see in detail view, you will see here gap between these two is 3.5 and 2.5 is the actual size of this, and this is going to start from bottom face 65 millimeter. So remember these dimensions. And here one more at another plane 20, 30, 10 millimeter height. This is also we are going to cut through all. Okay, first I am going to select front plane sketch. Now activate line tool, and I am going to keep this one as a center. Okay, now let me select this line construction, so it makes ease for drawing. Smart dimension, select this one. The length is 70 millimeter. Now select the this thickness, let me choose 6 millimeter. Similar here. Now outer to outer distance, see it shows, if I move my cursor outside it will show you diameter 70 millimeter. Now go to feature and activate revolve boss base feature. Now due to this construction line, it is asking you, would you like to close the profile? Say yes. Now see, by axis of revolution, by default it is selected by system. Now end condition, keep blind. Angle keep 360 because we want a complete solid body. Say okay. Look, I am going to add appearance from here, metal, steel, and this is going to be chrome. See? Okay, let's add rim, then we will add dome shape. For rim, I am going to select this sketch. Now convert entity, so outer line is converted. Again activate circle. Now draw one circle. Press escape key to out. Smart dimension. Now the gap between these two is 2.5. Okay. See. Now let's cut. Activate extruded cut. Now here I am going to select offset, and I am going to start from 65 millimeter. See. Direction downwards, and the depth 2.5. You will see. Okay. Linear pattern. Any plane, feature, extruded cut. Clear. Actually we need top plane. Now look, this is going upside, change. Now the gap between these two rings are 3.5. So you have to include 2.5, 3 number of instances, 2.5 plus 3.5. It's going to be 6 millimeter. Say okay. Here we go. Now here search command dome. You will see here, if you click this eye, it will show you where it's located. See, automatically it will show you. You will see this red arrow, dome. Click and activate. Now here I am going to make dome shape 5, select this face and just tilt. And look, this is how we are going to get a dome shape. Rest, show preview. If we choose elliptical, it will change the shape, but this is enough for us. Okay. Now select right plane, sketch, activate line tool, connect. Press escape key to out. Now let me do some corrections. Horizontal. Okay, let's do one thing. Connect this center point to this center point. Make this line vertical. Let's see what else can we do. 30 millimeter. The upper one 20 millimeter. This height 10 millimeter. Okay. Now one more dimension we have to fulfill. This center point and this line coincide. Now that's perfect. Now go to feature and activate extruded cut feature. Now this is located at center, so keep end condition through all both. So it's going to cut both sides equally. Say yes. Look. Smart. Activate fillet. First fillet type constant size, fillet parameter symmetric, and here put radius. Now let me select all radius. If I am going to select the first option, connected to starts loop 7. Now see, system detected all 7s and applied. Say OK. Let's see here. There is one hole, 5 radius. Then is one solid body, 7.5. Okay. Then there is outer one more cutout, depth diameter 18, depth 2.5. So remember this one, and height 15 millimeter. Okay. And this is located at opposite of this, means front plane. Front plane, sketch. Now activate circle. Smart dimension, and this is going to be diameter, radius 7.5 into 2, it's going to be 15. Distance from bottom, it's 15. It's still not defined, so press escape key to out of dimension. Press and hold shift key, select origin point and center point and make relation. If you leave shift key, you will see this pop up, vertical. Extrude. Now here select up to surface, select this surface. Now go to direction 2, and here also I am going to select up to surface, and this time I am going to select this. So it is going to connect inside to inside. Now say yes and see, this is created. Again going to select same front plane, sketch, draw one circle. Now here show this one, so that we will get center point. Smart dimension. Now this time I am going to activate 18 millimeter. Extruded cut. Now this is start condition, we will change 2 point surface. I am going to choose this surface. See, here keep blind. Okay, this is going to be start from here. You will see the preview. Just remember this preview. 2.5 millimeter going to cut inside. Look, you will see the preview. Say okay. Let's mirror this. Plane front, feature to mirror already selected. Partial preview. If you see full preview, it will show you both sides. So partial is enough. Front plane, sketch. Now here we need to make one hole. Select this one. Okay, let's create smart dimension, and this is going to be 5 into 2. It's 10 millimeter. Now move at center. See, it is fully defined sketch. Extruded cut. Let me change this one. Okay. Now here simply choose through all both. See the preview. Say yes. Look. Now let's save the first part. Go to desktop, create new folder. 90-degree V twin engine. Now this is part 1. Okay, we will change later this name. Let's do a new part. Select new. Okay. Now the next part is connecting rod or crankshaft. Okay. First we will make this web. You will see 50 R5, 10-degree corner 35, and outside radius 17.5. It means 35. Thickness 10 millimeter, and there is one circle. This diameter 25 and width 20. So let's make this. Then center there is a rod shaft 50 millimeter. Front plane sketch. Now I am going to draw. Okay, let's draw one circle. Press escape key to out. Again activate line tool. Draw one tapered line, something like this. Go back to the point and see the line is converted into arc. Move cursor and you will see tangent point. At that point, press left mouse and click. Press escape key to out. Now first important thing, select the center of this, hold shift key, select this, concentric. This is going to be good. Select this point, hold shift key and origin point, make vertical. This is also important. Now select these two, equal. Okay, let me draw one circle. Smart dimension. This radius going to be 50 millimeter. This diameter 35 millimeter. Center distance 30 millimeter. Now angle 10 degree. Now look, this is fully defined sketch. Press trim entity, power trim, and just trim this. Okay, now we have one close profile. Simply activate extruded boss base feature. Here choose blind. Start condition keep same. Blind 10 millimeter. It is moving in one direction. Let me push to other. Okay. I am going to activate fillet. Constant type fillet. Radius going to be 5, symmetric, and let me choose. Select this portion and you will see this option. Select this one and it will select all corners. Say okay. Look. Select this face, sketch. Activate here circle and place at this origin point. Draw one circle. Press escape key to out and activate smart dimension. And this is going to be 25 millimeter. Extrude. And how long this is going to be extrude? Keep end condition blind, and the depth of this 20 millimeter. Okay. Similarly, select this face, sketch, activate circle, keep cursor over edge and you will find the center point of this. Draw one circle. Press escape key to out. Now it makes this dimension 30 millimeter. No, not 30, it's 25. Go to feature and extrude. And this length of shaft is 50 millimeters. So keep end condition blind and 50 millimeter is the length. Okay. Now I want to mirror these two things. So first we have to create a plane. Activate plane, select this face and this face, and you will see a mid plane. See, we selected two faces and we will get this mid plane. Say yes. Go to mirror. Now plane is already selected. Go to feature, select 1 and 2. Clear 1, 2, full preview, even though from here you can select, and here add fillet. Okay. Now look, click hide. Now this time brush steel. Let me save this. This is going to be part 2, crankshaft. Save. Even though, let go to option, documents property, image quality, keep image quality higher so that you will get a sharp edge. Let's make new part. New part, plain white. I am going to do all the necessary things like documents property, image quality, keep higher. Now here the third thing is connecting rod. 130 length. You will see outer diameter 22.5, 13 millimeter inside one. R8 12.5 means outer one 25 diameter. Then there is a depth cutout 5 millimeter, depth 3 millimeter both side. So remember this, and thickness of this 10 millimeter. Let's say front plane sketch, activate circle. Now let me draw here 2 circles. Similarly at opposite upper side draw 2 more circle. Now let's do one thing, hold shift key, press and hold shift key, select both the center points vertical. Activate line tool, just click somewhere on the line and press at the place where you will get tangent point. Press left mouse and press escape key. Again press L key in your keyboard and activate line feature or line tool. You start from this time here, come to this, okay, here. Okay, let's start. $130. Now let's do the bottom one first. 22.5 into 2, 45. Similarly the inside radius 13 into 2. Okay. 12.5 into 2. R8 into 2. Now see, this is going to be fully defined sketch. Now activate extruded boss base feature. Now here we have too many close profiles, so you have to select all the profiles. Start condition same, blind, end condition blind 10. Now here in selected contour you have to choose all the 1, 2, 3. End condition keep mid plane, so it's ease during assembly. Okay. Select this face, sketch. Now activate offset, reverse, keep 5 millimeter. Okay, let's keep as it is. Again choose offset, $5 millimeter. One side, okay. Entities. Now activate trim entities. Power trim, just press and hold the left mouse and drag which line you want to trim. That's it. Activate extruded cut feature and depth is 3 millimeters. So here keep end condition blind and put the dimension 3 millimeter. It's going towards perfect inside. Now front plane, mirror entities, mirror feature, feature to mirror. Here you have to select extruded cut. You will see the preview. Okay. Now look both side. Select the body, appearance same. This is part number 3, connecting rod. Let's make new part. The last part, it is a kind of cover. This is going to be used as a block engine cover, 70, 80 the diameter, 110 length. Top sketch. Now activate circle and draw 2 circle from origin. Press left mouse on origin point and drag your mouse and see. Similarly do twice. Press escape key to out. Activate smart dimension 80 millimeter and the last inner one 70 millimeter. This is the piston diameter. Activate extruded boss base feature, and here I am going to select mid plane. Now length, total length 110 millimeter. Say okay. Now let's apply some color to this. Okay. Save. Part number 4, cover. Now let's go to file, open, and here activate assembly. Okay. Now here all the parts are already opened in my system, so it shows here, but we don't want this one first. I'm going to tell you now. Look, this is the assembly drawing, and there is some dimension we have to maintain before going to apply this. We will create some sketch to fit this assembly. 230 is the length of this. There is vertical lines. You will see here connecting rod distance from face 1, 45 millimeter. The position of first piston, gap 20 means 20 millimeter the gap between these two connecting rods. So first make this one, then we will apply, bring all the parts. So I'm going to choose right plane, sketch, draw one center line. Now this is the overall length. How much this length? This is going to be connecting shaft length 50, 10, 10, 70, 70 plus 20. It's 110 millimeter. Now exit. Now let's create one plane. Front, see, 45 millimeter first plane. Reverse. Okay. Now select the plane, sketch, activate center line. Smart dimension, length 230 millimeter. Okay, again select the length and select the point and it cancel. Select this origin point and you will see this triad, so select this one, and 90 degree is V twin engine, so 90 divided by 2 is 45 degree. Exit. Similarly again I am going to select which plane for this, front plane. Now 20 millimeter is the gap, so select this plane 1, reference geometry, again choose plane. Now gap between these two planes 20 millimeter. Flip side. Okay. Select plane 2, sketch, again activate and draw one something like this. Length 230 millimeter. Now this time angle going to be 90 degrees, so 45. Select this point, select this one, select this triad, 45. exit. Now just check 3D view. Oh, look. Now let's browse our part. Now first we will settle down crankshaft. Okay. Right click and make float. Now this is floating. Met. Select this circular and this one. And make sure selected concentric. Okay. Now here one more important relation we have to select. Select this face. And this is located at front plane. Look. Okay. Cancel. Now let's see. This is rotating along with this. This is what we like to keep. Now insert component. This time bring connecting rod. Activate mat tool. Select this one and this one. Keep relation concentric. Okay. Just move from here. Now we have to make distance. This distance 20 millimeter. If you calculate this from drawing 45 from one end, so we have to make one important relation. Front plane of this connecting shaft, a connecting rod, and let's check. We already create plane 1. Select plane 1. See, this is going to met at plane 1. Okay. Cancel. Now bring again piston. Just rotate component. Okay. Now select this one, met. Now select this line. Not coincide. Just check what it should be concentric, because this is going to move along with this. Okay. Now select this one, rod inside, and this concentric relation. Okay. Now I am going to check isometric view. Okay, this is going to be C. Now press and hold control key, select the part and drag and make copy. Again press and hold, click the part, drag and copy. Okay, let's create one by one all the relations. Activate met. This rod, shaft and the concentric relation. Now again we have to select connecting rod to front plane. That's it. And here we created plane 2. So select plane 2. Okay. Now this is perfectly aligned. Now let's align first. This is important, otherwise your geometry will be in mess. Okay. Met. I am going to select this surface and this one. And here again make concentric relation. This is important relation. Okay. Now rotate. Select this rod and this piston. Make relation concentric. Okay. Finish. Diametric. Look. This is how we created. Okay, let's bring the last part. Cover. Okay. Met. Select this outer face and this circle concentric, and one more relation. Select this face and this face coincide, but this is not concentric. These relation, choose concentric. Okay, fine. Again press and hold control key, copy. I am going to first rotate component. Okay, met. Select this one and this construction line, concentric relation. Okay, again select the face, outer face of this and end point of this, concentric relation. Fine. Click change transparency, click change transparency. Now first save this one, save all. Assembly, V twin engine assembly. Not this location is different, 90 degree. This is going to be our location. Now right click, go to toolbar and activate motion manager. Now go to motion study. Here keep animation and drag this one 8 second. Frame I am going to keep 60 so that we will get smooth. Now here activate motor. Select this one. We will keep 100 constant speed. First you have to choose rotary motor because this is going to rotate, not actuator. Face we already selected here. Constant speed 100 millimeter, 100 rpm. Say okay. Okay, this is going to drag up to 8. Now first calculate. Down. Now play from a start. Now look. If you want to save this animation, save animation. Now here let's keep the ratio as it is. V engine, even though you can change. Okay, this is going to cover 16:9 ratio frame per second 60. You just give the name, file size MP4, save. Now it is asking you, would you like to calculate? So this is going to calculate from start, and once the calculation finish, it will save in your destination. Don't forget to share, like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.